In this question, it is given that the three lines L1, L2 and L3 whose equations are these three are given. For which points Q on L2 can we find a point P on L1 and a point R on L3 so that PQR are collinear? First, I will tell you the meaning of question. According to question, suppose these three are the lines in three-dimensional space. Suppose this is the line L1, this is the line L2 and this is the line L3. For most of the points on this line, say this point, there exists a line which passes through this point and cuts this line also and this line also. But there are few points on this line from where it is not possible to find a line passing through this point and cutting this line also and this line also. And we have to find out of these position vectors which one are the possible position vectors of the point Q, so that we are able to find a line passing through this point and cutting this line also and this line also. Suppose these three are the lines. This is the line L2, this is the line L1 and this is the line L3. And a line passing through this point and cutting both these lines, say this is the line and this line passes through the point Q. The point where this line cuts the line L1, that line is P, and this is the point R where this line cuts this line. And because PQR are collinear, I can say the vector PQ is lambda times QR. I can speak in so many ways. I can say in this way also, the vector PQ is lambda times PR, or the vector QR is lambda times PR. There are so many ways of saying. Each one is a condition for the points to be collinear. Suppose position vector of the point P is lambda I. Position vector of the point Q is K plus mu J, means mu J plus K. And the position vector of this point is I plus J plus mu K. As in the question, he is saying which points Q on L2 can we find P on L1 and R on L3 so that the 3 points are collinear. That is, you have to find for which values of mu there exists lambda and nu so that these 3 points are collinear. And because I want PQR to be collinear, means there exists a real number alpha so that PR vector is alpha times PQ vector. PR vector is I plus J plus mu K minus lambda I is equal to alpha times mu J plus K minus lambda I. And now if the two vectors are equal, then the coefficients of I, J and K must be equal. Comparing the coefficient of I get 1 minus lambda equal to minus alpha lambda. Comparing the coefficient of J, I get 1 equal to alpha nu. And comparing the coefficient of K, I get nu equal to alpha. As I want there should be a point Q on L2, that is, there exists a value of mu for which all the 3 relations are defined. If I look at this, it clearly means mu should not be 0, because if mu is 0, then there will not be any value of alpha, and if there is no value of alpha, then lambda and mu will not be defined. Therefore, the very first condition is mu should not be 0. And if mu is non-zero, then I can say alpha equal to 1 upon mu, and putting this value of alpha here also and here also, I get 1 minus lambda equal to minus 1 upon mu into lambda, and mu equal to 1 upon mu. It is clear that if mu is non-zero, the value of mu surely exists. Therefore, there is no any problem in this relation if mu is non-zero. Now come to this relation. It is also clear that we will be able to find the value of lambda if 1 upon mu is not equal to 1. Because if 1 upon mu is equal to 1, then lambda will get cancelled and I will be reaching at wrong relation. Therefore, we will be able to find the value of lambda only if 1 upon mu is not equal to 1. That is, mu is not equal to 1. And if mu is not equal to 1, then this relation will become 1 equal to 1 minus 1 by mu into lambda. That is, lambda is equal to mu upon mu minus 1. Hence, if mu is not equal to 0 and not equal to 1, then the value of lambda and mu will exist. The value of lambda and mu will exist means the point P on L1 and R on L3 will exist. Therefore, out of these, only those can be position vector of Q which are in the form of this, and mu is not equal to 0 and 1. And comparing this and this, it is clear that mu is equal to minus 1 by 2. Therefore, choice A is correct. Similarly, choice B is also correct, because if mu is 1 by 2, the point Q will have position vector this. C choice is not correct, because K can become the position vector of this only if mu is 0. But if mu is 0, P and R will not exist, as I have already proved that mu is not equal to 0. And this is also wrong, because this can be position vector of Q only if mu is 1. But I have already proved mu is not equal to 1. Hence, I can say only A and B are correct choices.